All right. Time for another great day of formal methods. And I just handed around some graded homeworks from last time. And I think you have an assignment due today, so we'll start by seeing if there's any questions. You guys were chit-chatting over here about the homework I see. Did you have some questions?
For B and C,
Okay.
it says x gets x minus 1, and then it's the precondition x squared plus 2 times x equals 3.
Okay, hold on. Let me find where you are. It's
1.11.
oh, 1 point.
1.1, and then B.
Oh, 1.11? Yeah, it's giving you, right, it's giving you the statement and the post condition, and you just have to do the
I
precondition.
was wondering if, no, we have to do the post condition, right?
No,
Oh,
you
wait,
do the precondition.
We're doing the precondition.
Right.
I was wondering if, for B, there's 2 answers,
Actually, there's not.
or can be.
No, actually, there cannot be 2 answers.
Okay.
For part B, you have to do, whenever you do the textual substitution to calculate the precondition, you have to do it on the entire, you have to do the textual substitution of the entire postcondition.
Okay.
So there's not 2 answers on that, there's only
So
one.
it's only the x minus 1 squared in parentheses plus 2 times x minus 1 equals 1.
Yeah, you just stated the answer. Right, you do it to the whole thing. You have to do it to both x's, both the x squared and the...
Wouldn't a proper precondition also be one that is only substituting the
No, it would not. Yeah, you have to... Yeah, in other words, with that one, this is 1.11b. You have to do it like this. X squared plus 2x equals 3. And this whole thing has to be textual substituted with x gets x minus 1. All right? And so there's only one answer.
I also had a question on 1.11. Do they all have to make mathematical sense?
No, they do not.
Good.
Why, does one of these not make mathematical sense?
It was E and I think D and E.
Yeah.
Yeah.
X plus y equals x and y.
Yeah. Because if you work back.
No, hold it. Oh, no. Actually, I think,
So if you work from the precondition to the postcondition,
what do you get for the precondition?
x plus for D, x plus y equals x.
Well,
And if you substitute every y for an x, then you have x plus. Then you have
there actually is a state for which that would work, I think. But anyway, to answer your question, it doesn't have to make mathematical sense. In other words, formally, the only thing you really have to do here, this is just another exercise in textual substitution, right?
Yeah.
Because that's what the Hoare triple says. Okay, so
Okay.
so if this is a Hoare triple, what's the interpretation of a Hoare triple?
If P is true
If P is true
and S is executed,
and S is executed,
then R is guaranteed.
well, one more thing.
It follows.
Starts with a T.
And terminates.
Yeah, S terminates and R is guaranteed to be true. Yeah, it's hard to get that until you've done some programming. Those of you who have done some programming, have you ever written an endless loop?
Yeah.
You know, it just keeps spinning. You know. Well, that's an example of a statement, a group of statements executing that don't terminate.
Right.
See, so this one presupposes that S terminates, and then that's why we have to put that to make it complete. Right? Well, what about any questions about the exercises on chapter 2? Doing this truth table kind of stuff?
No.
Oh, by the way, I always get somebody. Notice in the on the web page, I always get a few people who think that they have to do all parts of the problem. But I only gave you, you know, I just gave certain. Yeah, it'd be really tedious to have to do the whole thing. So you don't have to do the whole thing. Actually, now that I'm thinking about that, let me make a comment, point out something here. For your next assignment. Yeah, so here, A3, with A3 you only have to do parts A, B, C, D, G, and J, and for 2.0 you only do D, E, and H. But now here's something for the next assignment that you have to be, it's a little, it might be easy to misunderstand this. Now look, first of all, there's a handout. I'm going to give you this handout later today. And you're supposed to do exercises 2.3 D, E, and H, and 2.4 B, D, and F. But also you also assigned as exercise 2.5, and also assigned as exercise 2.7, and also assigned is supplementary exercise S.1. Now, as we go throughout the semester, there are some exercises that I have written that are not in the book, and those are called supplementary exercises. And it's not optional. Okay, so that's part of the assignment. All right, so
What's all the notes for
yeah, you'll see.
5?
Yeah, you'll see. We'll go over that when we get to it. Today we're going to one of the things we want to get to today is translation between a formal Boolean expression and English. So we're going to start doing word problems.
Lovely.
Okay. Okay, so are there no more questions about the homework for today?
Not.
You're good? Yeah. Question?
Turn it into your office later today.
Sure. Yeah, and so you can turn it in, if you don't have it after class, you can turn it in at my office. If I'm not there, there's some boxes by the side of my door that you can slip them in. Did you have a question here that we can help you with? Oh, okay. Are you good? Are you good? You got your question answered?
Well, on 2.2H.
Okay, on 2.2H.
Yeah.
See, it's always kind of good to get this on the video, because 2.2H, because if you have a question, then it's possible that the people who are watching the video will have the same question. So 2.2H. Oh, that's kind of a complicated one. Office number is RAC 212. No, sorry, 112. RAC 112. Okay, so. Okay, so it's B equivales C equivales B implies C, and C implies B. This is the question, right? So, I mean, basically what you have to do is go B, C. Now, do you remember the order we said you had to do this in?
Yeah.
It's T, 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 F, F, T, F, F. And so, okay, so what's your question?
I don't know.
You mean how to start?
Solve it.
Well, look, here's the thing. This whole thing is either true or false when B is true and C is true.
They're all true.
Don't spill the beans.
I know that one, but then the next two, the middle two. I don't know.
Which, you mean this one?
No, like the true, false, and the false, true. I don't know if those are true or false.
Okay, well look, the way you do this is first you do a column for B equivales C, right?
Yeah.
And so here is B, oops. So here is B equivales C, okay? Now, and here's B and here's C. And so you go down and you say, true equivales true. Is that true? Yeah. true equals false. Is that true?
No.
Now do you remember the truth table for equivals?
Yeah.
How did the equivals work? If they're the same, it's true. If they're not the same, it's false. Okay, so true equivals false. That's false. Are you with me? And then false equivals true. That's what? That's false. And then false equivals false. That's what? That's true. All right. So you see, we did that. So we did that for this one. All right. Now the next thing you should do is do another column for this one. Are you with me?
Yeah.
And then the next thing you should do is do another column for this one. All right? And then the next thing you should do is take the column that you did for this one and the column that you did for this one and do what? And it. And what was the rule for and? Remember how what the truth table for and was? They both had to be true. Okay, so you do that. And then after you do that, you'll have a column for this and you'll have this one for this one. And then you do the equivals between those. No.
No.
Well, I mean, if you want to do it all in your head, I guess that's fine. But, because why?
It's a lot simpler to just do it in your head.
Yeah. Well, I mean, yeah, you can do as much or as little in your head as you want. But I think if this is the if you get lost, this is the way to do it. I mean, if that's too much to do in your head, yeah.
So, do you do and before the equivals because that's a higher precedence?
That is a very, very good point, and the answer is yes. Did everybody hear that? And has higher precedence than equivals. So you should not do a column for this and then and it with this. That would be wrong. And you have to know the precedence. Yeah, that would be a potential source of error if you don't keep that in mind.
Do we do the precedence?
Don't you remember that table that we looked at?
I didn't, but I did it like that, so it's fine.
Well, yeah, but you better check. I mean, you better always check. You know, it's in the inside front cover of your book.
The book that I don't have yet?
Is your book still not here?
It's still in the mail. I'm gonna
Okay.
check on them people.
Okay. Well, anyway, it's inside front cover of the book,
Alright.
and yeah. All right. Did that answer your question, Mason? Are we good?
Yeah.
Okay. And so you remember how was the B implies C? What was the truth table? What did the truth table for that look like?
True.
It's usually what? Is it usually true or is it usually false?
Usually true.
It's usually true. There's only one time in which it can be false, and that's if what?
True. and
If
false.
B is true and C is false. That's the only way it can be false. That's how that truth table works. Right? Okay. All right. Let's move on then. The next thing we have is a little vocabulary. We have some definitions here. All right. The first definition is satisfied. Are you satisfied? I can't get no satisfaction.
It's a good song.
It is a good song. Okay, but anyway, a Boolean expression P is satisfied in a state if its value is true in that state. Right?
Definition of what?
I'm sorry, question again?
It says definition up there?
Yeah, this is the definition of satisfied.
Oh, that's what.
The definition of satisfied. P is satisfied in a state if its value is true in that state. For example, here's an example. B equals C is satisfied in the state B true, C true. It's not satisfied in the state B true, C false. So everybody see what satisfied means. Okay? P is satisfiable if there is a state in which it is satisfied. In other words, if you can find a state, then in which it can be satisfied, then it is satisfiable. Actually, let's do some examples as we go here. Consider the Boolean expression P and not Q. Now, what about P and not Q? In the state P true, Q true. Kyle, what do you think? If P is true and Q is true, is this satisfied, yes or no?
P and no.
Correct. It is not satisfied. So this is not satisfied in the state P true, Q true. Whoa! I just tripped on the piece of furniture over here. Okay, so P and not Q is not satisfied in the state P true, Q true, right? Okay, but here's my question. What do you think, Josh? P and not Q. Is it satisfiable?
Yes.
Yeah, it is satisfiable. And how do you know that it's satisfiable?
Because Q could be false and P could be true.
And in that situation, yeah, Q. What he said is Q could be false, P could be true, and in that case, P and not Q is true.
Yep.
Is everybody clear on that? Because this would be true and true. If Q is false, not Q would be true, and then true and true is true, right? Does everybody see this is satisfiable? Now, what's the next definition? P is valid if it is satisfied in every state. Well, is this valid?
Nope.
Why not?
Pick anything other than the one I just said, and it's
Yeah.
satisfied.
Yeah, is not valid. Okay, so my next question is it a tautology?
No.
Yes.
It's not valid.
No.
No, it's not, because valid and tautology mean the same thing, right? So P and not Q is not a tautology. All right? How about this one? P implies, we're doing another example. How about P implies Q equivales not P and not Q. What do you think about this one? Is this satisfied? Or I would have to give it a state. Is it satisfiable? Is it valid? Is it a tautology? What do you think? Well, yeah, we'd have to pick a state.
P true, Q true.
Say it again.
Just the first one, if they're both true.
Yeah, say if they're both true. Yeah, let's see if it's satisfied in that
I
state.
think it is.
Well, this would be true implies true. What is that?
That's good.
That's true. And then this would be true and false. So that would be false.
But not false.
But not false is true. So we would have true equals true. So that is true. So it is satisfied. It is satisfied in true, true. So it's obviously satisfiable because we just found one, right? I wonder if it's a tautology. Let's do this. Let's do P,
It's
Q.
not. True, false.
True, true, true. You think?
Yeah, true, false.
Yeah.
True breaks it down.
No, true works.
No.
I don't know.
As long as
Oh, wow, this is interesting. You guys, some of you guys are... Okay, how about P implies Q? So, P implies Q. So what would that be?
True false doesn't.
True...
Does it?
No.
Wait. Let's try it. True...
False at the end. Sorry, what?
Okay, so what's P implies Q?
True.
True,
You're right, that's false.
False.
false,
True.
true,
True.
true. Is everybody clear on that? Have you memorized your truth tables for implies? No? Yes, no? Be honest.
Just know it.
True. Was this the one that was false?
False.
Yeah.
False,
True.
true, true. And then how about, let's do P and not Q. So let me see, not Q is going to be what? Let's just do not Q in our head. Not Q is going to be what?
False.
False, true, false, true. So this and, so this would be true and false, right? So what is that?
False.
False,
True. True. False.
true.
True.
This would be false. Wait. P and not Q. This would be false and false, right? This would be false and false, so that's false. And this would be
False and true.
false and true, which is false. Does everybody see how we're getting this?
No, no idea.
Okay,
kidding.
we're doing this and not this, right? Okay, now if we negate this, that's easy because this not P and not Q. So if is all we have to do is negate this, right? So if this is false, true, false, false, that makes this what?
True, false, true, true.
True, false, true, true. Is everybody? And son of a gun, this and this. So therefore, P implies Q equivales not P and not Q. Turns out to be true, 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 right? Because the same, the same, the same, the same. It is a tautology. This is a tautology. Is it valid? Yeah. This means the same thing. It's valid. It's a tautology. Valid. Oh, actually, we talked about valid before, right? Remember what we said valid was? True in all states. There it is. True in all states. Okay, now the next thing I'm going to write down is not in the book quite this way.
That's valid.
But we're going to need this concept later, so we might as well introduce it now. This is a piece of vocab that's not in the book yet. It's called a predicate. A predicate. I'm going to be asking you this many, many times. I wonder if our cameraman remembers what a predicate is. I would like to put some money on it, but I won't. Do you remember what a predicate is? Okay. A predicate, get this. A predicate is a function that returns type Boolean.
Okay.
A predicate is a function that returns type Boolean. Okay, and remember what type Boolean, what are the possible values that a Boolean variable can have?
C, A, X, and Q.
C, A, yeah, true and false. Those are the two possible values.
Following that, though, that made sense.
What? You guys can't be throwing me all these curveballs. Come on. All right. Well, you think it's easy now. Just you wait. Okay. Let me give you an example. For example, odd x is a predicate. This is a function that returns type Boolean, right? So if you say odd 5, what does that return?
No idea.
True.
Yeah.
What does odd mean?
It's whether or not this is an odd number.
Oh,
Okay, so odd 5 returns true. And odd 6 returns what?
false.
Returns false. Okay, so that's a predicate.
Is that a C++ function thing?
Well, it's in some languages. Yeah. But it's an example of a predicate. What's a proposition? Remember we had a proposition?
Function that returns a variable?
No, we defined a proposition before. Remember we said,
No.
can I have a cookie? Is that a proposition? Don't you remember that example?
We didn't do this.
Yeah, we did.
We didn't do this. You saw my notes.
Yeah, we didn't do it.
Oh, maybe
Yep.
maybe we haven't done it. Oh no, you're right. I'm mixing up a rehearsal for this camera setup. Never mind. That's coming later. Okay, anyway. But a predicate is a function that returns type Boolean. Now, I'm going to give you another example of a predicate. It's called valid. Valid P. Now, what do you think valid P?
True if it's valid.
Yeah, returns true if P is a valid Boolean expression, false otherwise. Okay. So valid P returns. We'll say valid P is a predicate. That returns true if P is a valid Boolean expression. And false otherwise. Okay, but the key thing is that it returns Boolean. In the same way, odd 5 returns true, odd 6 returns false. What do you suppose valid P and not Q?
False.
That returns false because we saw that P and not Q with the example, we saw that P and not Q is not valid, right? So this returns false. And the other one was, what was that long one? Valid, what was it? P
implies Q.
implies Q,
Equivales.
equivales,
Not parentheses P and not Q.
not
Parentheses.
parentheses, P and not Q. That returns what?
True.
Returns true. Because that is a valid expression, right? Okay, now, this next thing that we have to learn is more definitions. Is the definition of dual. Okay, and this one's in the book, so I'm not going to write it on the board. It's 2.2 in the book on chapter 2. And the definition is the dual of an expression. Sorry, we just got to plow through all these definitions. It's like learning any language. You just got to get the vocab down before you can start doing the interesting stuff. But this is a pretty easy thing to do. We have a little recipe here. So now what do we say a capital letter represents? An expression as opposed to a single variable, right? Okay. So P is an expression. It could be an expression like this Boolean expression or this Boolean expression. Okay, it's some Boolean expression. And if we have some Boolean expression P, this is the definition of the dual of P. So this P sub D means the dual of P. And we have this little recipe, and it's a very simple recipe. The recipe is you take your original P, and everywhere there's a true, you make it false, and everywhere there's a false, you make it true. Yeah? Easy enough, huh? And everywhere there's an and, you make it an or, and everywhere there's an or, you make it an and. Yeah? And everywhere there's an equivales, you make it not equivales, and everywhere there's a not equivales, you make it an equivales. Everywhere, what's this one called? Everywhere there's a what?
Implies.
Everywhere there's an implies, you make it what? What was going the other? Not what?
Not come from.
Starts with an F.
Follows from.
Not follows from. Okay, so everywhere there's an apply, you make it not follows from. Yeah? And everywhere there's a not follows from, you make it implies.
Does not imply.
Everywhere there's a not follows from, you make it and implies.
Oh.
Okay. And everywhere there's a follows from, you make it not implies. And everywhere there's a not implies, you make it follows from. That's the recipe. Okay? So, does everybody understand how that recipe works?
Yeah, let's do it.
All right, Josh, since you volunteered, what is the, if P is the expression P or Q, what is the dual?
Not P and not Q.
What do you think? Do you agree?
Just taking a leap. No. Leap of faith.
I think it's
The he said not P and not Q.
Because
What?
he wanted to switch all the trues and false
Is it?
Whoa.
if they had values. Are we
Oh.
No. This is just an expression. I mean, we're not talking about values or anything. We're just talking, this is an expression. This is the recipe. So, what do you think, Kyle?
You can just do that.
Kyle, what do you think?
Then it's probably just P and Q.
Yeah, it's P and Q.
So is that wrong to jump ahead and try to switch all the values?
Well, yeah, that's wrong. Whoa. There is no true in here. There's no false in here.
Yeah, but if it was.
Well, I know, but there's not, so we don't, I mean,
All right.
yeah, but anyway, you see how the recipe works. Okay, so Ben, what do you think? P implies Q. If P implies Q is the,
Does not follow from Q.
okay. P does not follow from Q. You want to do the next one?
P does not equal not Q, or not P.
P does not equivalent not P. Okay, good. Oh, you get the hard one. Now, so what is this?
False.
So instead of false, not equivales, true or P, what will this one be?
True.
True.
Equals false and P.
True equivales false and P. You agree?
Yeah.
True equivales false and P. And, okay, Josh. Not P, oh, by the way, here's where you get the false to the true and the true. Oh, okay.
I noticed.
Okay, so, so, and what do you think on this
All
one?
right, not P or not Q, not equivals R.
R. Not P or not Q, not equivals R. Good. All right? Now, so everybody, this is just a recipe, yeah, to do it. Now, on the next slide, I'm going to show you, it's written a little bit differently in the book. And because the book does not use this little idea of the predicate. But this is called a meta-theorem. Have we used the word meta-theorem before?
No.
Well, we haven't actually used the word theorem before yet either. So let's just kind of skip over what the meaning of a meta-theorem is. A meta-theorem is a theorem about theorems. But we'll get to the meaning of meta-theorem later. But at least this is meta-theorem duality. Now, and there's two parts to this meta-theorem duality. And I think that knowing what valid means and knowing how to construct the dual, I think we can understand what this is saying. Whether or not we believe it is a different story. And so what is this saying? This is saying that
If P is valid.
if P is valid, that's equivalent to what?
P, not the duality.
Not the dual of P being valid. So you know how we did that that long expression, boom, 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 and we said, whoa, and we did all the true, false, blah, 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 and the conclusion was that was valid. Remember we said that was valid? Well, what you can do with this, without having to write another truth table, what you can do is you can take the dual of that and then put a negation in front of the whole thing, and that will be valid.
So does the dual always just flip the sign of?
Or flip it from true. If it was true, then the dual of it will be false.
No, that is a good question. The answer is no. The dual is not the same thing as the negation. And that is actually that's a common mistake. Some people think that the dual of an expression,
If that was true, then that expression would be true as well. The meta-theorem.
well, the point is that the point is that I think this might have been what you were saying. P and not PD. These are not the same expressions.
Okay.
These are not the same expressions.
But they do.
But yeah, and that actually that's a typical source of confusion. Some people kind of jump to that conclusion. These are not the same expressions. But what that meta-theorem says is that if this one is valid, then this one is also valid. And if this one's not valid, this is also not valid.
How does just the dual relate to P?
With this recipe. This is through this recipe.
The dual isn't necessarily valid?
Well, if this one's not valid,
And this one also.
well, then the negation of the dual is not valid.
Right.
So the dual is valid?
Can we see
Or
an
do we not
example
know?
with
Not
to
necessarily.
illustrate how they're different?
Yeah, okay, yeah, maybe we should do a simple example. Let's do here.
The first one up there.
Actually, this is a good one. This is a good one. These are examples of dual. P or Q is not. Oh, okay.
Or, that's not true. It's true, 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 false.
Yeah. Okay.
Do that
Okay. Hold on. Let's do this one. P or Q. Okay. So if P or Q is the expression, the dual of the expression is P and Q. Now what this is saying is valid. Now watch. Let's do an example. Valid P or Q equals equivales valid not P and Q. Are you with me?
Yeah.
They're both false, or they're both not valid.
Yeah.
All right. And what this is saying is that, well, P or Q is not valid, right? And furthermore, if you do this, if we do P and Q, so here if we do P and we do P and Q and then we do not P and Q.
Okay, but if P or Q is valid, that means that P and Q is the opposite every single time.
Wait, don't say opposite. That we haven't defined opposite. We only talk about duals and negations. Okay, but hold on. Let me follow through with this one. So,
It's P or Q.
oh, sorry. This is not P or.
No. Which side are you doing here? Are you doing both sides at the same time?
Yeah, I'm doing P and Q, and then I'm doing not.
The first
Oh, this one should be. I'm sorry. This should be not P or Q.
No.
No, it's
Oh, wait.
The other one. On the your
Darn.
truth table, it's P.
Your truth table, it should be left and then the right. Your left is an or.
Oh, I see. Okay. Now let's see if we can get this right. So this is P or Q. This is not P and Q. Is that right?
Yeah.
And now, let's do P or Q, and now let's do not P and Q. Okay. So what I'm saying is that P or Q is going to be what? What's that going to be?
True,
False. True, false. So this one's not valid, right? Are you with me? Because of why? Because of that. And how about this one? Well, let me see. P and Q is going to be what?
false and false.
Let's just do P and Q in our head.
True, false, false, false.
True, false. So that's going to be, so not is going to be what?
False, true, true, true.
False, true. And so this is also not valid. See? Now that's an example of how it works. Are you with me on that?
Okay, my question now.
Okay, now your question.
You know that one example that we did for seeing if something was valid, right?
Yeah,
that big ugly example.
Yeah.
Was valid.
it was valid.
Okay, so given that that's valid,
Yeah,
so that expression is true.
in all,
State.
yeah. So what I'm,
That means the duality of it is false in every state.
actually, that is right.
Yeah.
So that's how it's.
So that's what I
Okay.
meant by the opposite bit.
Oh, I see, I see. But that's in the special case of it being
So
valid.
if it's valid, that means that the duality
It
is false in every state.
correct.
That's why you
Yes,
do that.
but that's only, but this says more than that. Because this says, not only if this is valid, the negation of the dual is valid, it also says if this is not valid, the negation of the dual is also not valid. I mean, see, so this says more than that. Are you with me? So I think you made an observation about a special case in the case where it's valid.
Right.
Are you with me?
Yeah.
Then you get it. It's valid.
Man, you guys are sharp.
Thank you.
This is a very good, deep discussion. I think everybody's got it. Is everybody? Are we good? So here's the example in the book. Here's an example of some. Unfortunately, I think what he does here is he's doing all valid ones. You know, he's doing the case where it's valid. So clearly, true is valid, right? So the dual of true is what? False. And then not false is also valid, right? And then here, P or true. That's valid, right? Because true or anything
We can just skip this.
is true, okay, and then not. And then the dual of this is P and false, and then not P and false is also valid, etc., etc. But now there's another part to it. Notice up here, there's another part to this. Not only does it say valid P equivals valid not P, it also says valid P equivals Q is the same as valid P dual equivals Q dual. So now this one only had a P in it, but part B has a P and a Q in it.
And not a negation.
And not a negation. Yeah.
Yeah, that makes sense.
Oh, you think it makes sense?
That makes sense.
Yep.
No. Yeah, that makes
You can leave it up there for a second.
Okay, and so he's got some examples here. He's got these examples with, you know, P or Q equals Q or P. So therefore, P and Q equals Q and P. You know, some examples. Okay, well, we need to go on. And by the way, I will say that this is just a statement of fact. We're not proving it. You'd have to,
But you can.
yeah, you could if you wanted to. Yeah. Okay, now for next time we're gonna do for next your assignment, your homework assignment for next time, we're gonna do some translation. So these are word problems. You know how did you guys like word problems in algebra?
Yeah.
I'd love to. No.
Most students don't like word problems. They just want to be able to mechanically do the algebra. They don't like to set it up.
Applications like that. Not necessary.
So these are formal method word problems. Okay, and here's what we have to be able to do. Frequently, you will be given a problem in English. All right? And in order for us to make sense and to do some logic on that statement, the first step we have to do is we have to translate it into a Boolean expression. Are you with me?
Sure.
And here is the recipe. So translation into a Boolean expression, to translate a proposition P into a Boolean expression, what you do is you have to identify a phrase of the sentence and make it a letter, make it a variable. And then the key English words that you look for are the words and that obviously is conjunction, right? Conjunction, that's the and. Or becomes disjunction. Are you with me?
Yeah.
Not becomes this negation. Yeah. It is not the case that.
So not.
is the same as not, you know. And anytime you hear the words if then, if P then Q, that becomes P implies Q.
I like it.
Yeah?
So do we define a proposition?
Include these.
Or we just kind of jump in?
We're about to-
Oh, actually, a proposition is a statement that is either true or false. It's an English statement that is either true or false.
It can be done a different way.
Well, okay, it could be in German,
Okay.
but not French. Just kidding. Okay. Okay, for example, let's suppose you have this proposition. Henry VIII had one son, or I'll eat my hat.
Okay.
Now, the first thing you have to do is you have to say, well, Henry VIII had one son. That is a phrase, and we assign a letter to that. So what we're going to do is we're going to assign X to that. Yeah? And then, I'll eat my hat. Okay, we're going to call that Z.
Okay.
Well, if that's the case, if Henry VIII had one son, or I'll eat my hat, is the statement that we want to translate, and if Henry VIII had one son is the letter X, and I'll eat my hat is the letter Z, then, Ben, what is the translation into Boolean algebra?
X or Z. The little
X or Z.
That sounds like fun.
And Rochelle, what happens if Henry VIII had one son and one is not prime, provided that W stands for the phrase one is not prime?
One is prime.
Is prime.
Wow, I didn't know all you guys were named Rochelle.
No, we're helping you out.
said it.
X and
Problem,
not W.
W is one is prime.
Right, so not one is not prime.
Okay, so what are the letters? What is the
So
expression?
X and not W.
Yeah, correct. Does everybody see how that worked?
Yep.
Okay. And now, shall I ask Rochelle again so everyone else can answer? Mason, what do you think? If one is prime and Cleopatra had two sons, I'll eat my hat.
So, W and
W and
Y
Y.
equals or equal fails.
Not equals, not equivales. Let's go back.
Oh wait. Then.
If then.
Implies that.
Okay, so.
Yeah.
Okay, so say it again.
W and Y implies Z.
Good. W and Y implies Z. All right? Now, there's, and then you can read some more stuff in the book about that. Now, I have a, how much time do we have? Just like about a minute, 2 minutes? Oh, well, we can get started. Okay, now, I have a handout that I'm going to give you next time. All right, so all of this stuff that's on here, you don't need to write it down because it's all on this sheet, but I just want to go over this with you before I hand it out. All right? So there's no need to take notes on this. But there's a group of English phrases that we have to know how to translate into Boolean expressions, and these are not described in the book. And that's why I'm giving you this supplementary exercise to do on Thursday, okay? The first phrase is the following. Now, it's P, comma, if Q. Now remember, we said if P, then Q is translated how?
Implies.
Yeah, so what implies what?
P implies Q.
P implies Q, right? But now this is saying, it's switched around a little bit. It's P, comma, if Q. So here's my question. Do you think this is Q implies P or P implies
Q
Q?
plus P.
Q implies P. Or P.
Anyone else?
I was going to say P follows from
P
Q.
follows from Q.
I still think it's Q.
Well, P follows from Q is the same as Q implies P.
Q implies P.
So
Q implies P.
okay, so same as Q implies P. Good. All right. Now, there's one more before we quit today. And this is really
Would
something.
only do.
Okay, this is P only, this is P only if Q.
It means Q. Oh, wow.
Yeah. the absolute value of Q.
No, what absolute value? There's no absolute values in Boolean expressions. There's only and, or, not. Absolute value. Square root of, what's the square root of true? True squared. What's,
Is there a Q must imply?
well, it either does or it
Yeah,
doesn't.
it's
So it's just Q implies P.
It's Q implies P. But nothing
Well,
else.
no, because then
Only if,
assuming okay, in the sense that if Q is true and P is false, Q would be true and wait, give me a second.
I see, I've got you stumped. I
Is it
have,
just Q?
I've got you
False.
stumped. Is it just
False
Q?
and P is true.
I got you guys stumped.
That's impossible.
Okay, this is a big mystery.
You got me.
This is a big mystery. We're going to have to clear it up at the beginning of class tomorrow. All right? So how's that for a cliffhanger? Okay, so see you tomorrow.